Okay, so today we are going to solve the Chapter 19 Geometry Introduction to Geometry challenge problem. There are 27 questions. I will divide it into the 3 videos, and each video solve 9 questions. Okay, so let's start. First one. So we have the right triangle. Okay, the right triangle and the right angle is x, and then we have y and z. So it mentioned the p is on the xz, and the triangle folded over the yp. P is here, yp, so that x lands on the yz. Okay, so we have a line of the yp, right? Then we fold this x. The x can be lined on here. So basically it's a symmetry, right? So you can see if we fold it on this line, then this one is mapped to the x1, right? So you know, because this folded line, so these two triangles, okay, the triangle yx1p is congruent to triangle yxp. Okay, so you know this is the angle bisector, right? And the next one we know is the py equals pz. Py equals pz, so you know this is also the isosceles triangle. So we have the xy equals 6, so we have this one equals 6. And then we want to find angle xyz, right? So we want to find angle xyz. So because the triangle ypz is the iso triangle, right? So you know the px1 perpendicular to the yz, then you also know px1 is also the perpendicular bisector of the yz. Then you know the zx1 equal to the x1, or yx1 equals to the 6. So you know this is 6, right? This is the right triangle, right? So 6.5. So you know this one is 30 degrees, right? This is the 6 and the 12 and the 6 square root of 3. This is this triangle, right? So now you can see the x, z, y. So angle x, z, y equals to the alpha equals to the 30 degrees. Okay. Next. So yeah, so this is the inscribed of the inscribed of the square, right? So let's draw the picture, draw a big picture. So I have a right triangle is ABC. Then I have this one is 90 degrees. So I have a square. Here is the LM and P, right? So this is the square inscribed here. So I know the Pn is equal 6. So I want to compute the AP. Let's see, AP times the NC. Okay. So first is AP is x and NC is y. So you can see because this is 6, this is 6, right? So consider about the x and y. We have we have a similar triangle. Let me mark some angle here. So this is the alpha, right? So this is the 90 minus alpha, and also this is 90 degrees. So this is alpha. So you can see the triangle, the APL, will similar to the triangle of the M and C. Then we could have the x over 6 is equal to the 6 over y, then you can see x times y is 36. So this is the answer. Okay. Next. So here is we have the 4 circles of the radius of 2, arranged that the each is tangent to the other 2. So this one tangent to this 2, this one tangent to this 2, right? Okay, so let's see the point, the center are A, B, C, D. A, B, C, D. Then we can connect it the A, B, C, D. Then this will be and ABCD and AB will pass in the tangent point, right? So here is we know it's 2 and 2, so this is the square, the side length is the 4, right? And we want to find a center here, so you can think we want to find a circle, right? That is tangent to all the 4, because by symmetry, right, we can do this. We can connect it here. So this must be the center. And then you can see, then you can see okay, so if this is the radius and this is the radius, right? So it's 2 of the radius. So now we can set up equation is AB equal to the, let's say this radius is x, is 2x, right? Plus the 2 radius. This radius is 2, right? 2 times 2. So now you can see the AB is 4 root 2 equal to the 2x plus 4. Then you know the x equals the 2 root 2 minus 2. Okay. Next. Okay. So here and we see the triangle ABC and PQR both are equilateral triangles. Okay, and the AQ and the BP and RC are congruent. So this, sorry. So this sides equal this sides equal this sides. Okay. So we have the 4 interior have the same of the area. Okay. So means this is S, this is S, this is S, and this is the S, right? So now we know the triangle PQR and over triangle ABC is equal to the S over the 4S is 1 over 4. So now we know the side length, the PR over the AB is the square root of this, right? Is 1 over 2. 1 over 2. Okay. So now you get AB is 20, right? Now you know this one is 10. Okay. Now let's do let me draw a big one. So I have 20, I have 10, right? So let's draw to the center. They share the same center, right? So that's this. Okay. So we want to calculating let's calculating the x. Okay, this is the x. So now you can see, right? So this one basically is the midpoint because it is parallel, right? So this is the midpoint. So here, so that's why the x is equal to, this is also x, right? So then we know the 2x is equal to then this is a 30 degree, right? 2x is equal to 10 over cosine 30, right? Cosine 30 degrees is 10 over root 3 and 20. So that one your x equal to 10 root 3. Okay. Next. Yeah, and the next question. Let's see, P is inside the rectangle ABCD. A, B, C, D. Okay, then we have the P is inside of the A, B, C, D. We want to prove that AP square plus CP square equal to BP square plus DP square. Okay, let's do auxiliary lines. Okay, so this one is cutting this into 4 regions. Okay, so now let's do now let's see. Okay,
Can't find the one.
now let's see is, for example, it's the this is the X, this is the Y, and this is the U, and this is the V. Okay, so now let's parameterize the APBP using the XYZW. Okay, so AP square is equal to this is the X is equal to the X square plus the V square, and the CP square is equal to the Y square plus the U square. Okay, then on the other way we can see the dp square is equal to the u square plus x square, and the bp square is equal to the y square plus the v square. Okay, now let's sum of them together. Let's see. Okay, so AP basically you can see is x squared plus y squared plus u squared plus v squared, and this one is also the x squared plus y squared plus u squared plus the v squared. So you can see they are equal. Next. So the w, x, y, z is a parallelogram. Now let's do it. So we have a parallelogram. Okay, we have a parallelogram of the w, x, y, and z. Okay, now we see the m is the midpoint of wz, and o is the midpoint of the yz. Okay, so basically this is the midpoint segment, and the mo and xz meet at n. mo and xz meet at n, right? So what we want to find, what is the zn over xn? Okay, let me do an auxiliary line of this. Okay, so because ABCD because the WXYZ is parallelogram, right? So now you know the ZX and the WY are the diagonal. They are bisect each other, right? Bisect each other. Okay, so this means, let me parameterize something. This means, I mean, if this is a 2t, right? So this is the p, right? So if the xp equals zp equals 2t, right? And the mo is the midpoint segment, right? So you know that Zn also equal to Np, right? So that's why this one are 2t divided by 2 equals t. So now we can see the Zn equals t and the Xn equals 4t minus is 2t plus t is 3t, right? So the Zn over Xn is 1 over 3. Next. So in triangle ABC, let's do it in triangle BAC, in triangle ABC, we have the BAC equals the 60. This is the 60, and the ACB equals the 45. Okay, and the D is on the BC, such that AD equals 18, and BAD, say BAD. BAD equals CAD. BAD equals CAD means the AD is the angle bisector. Is angle bisector of BAC, right? So now you know this is 30 and this is the 30, right? So now let's try to figure out some angles. So 60, 40, 45, so we know this angle is 75, then this angle is 105, then this angle is 75, and this is 18. Wow, so you can see the triangle BAD is a 75, 75, and 30 triangle, right? So means it's isosceles, means AB equals AD equals 18. Okay, then we want to find the triangle, the area of triangle ABC, right? Okay, so now in order to find the area, we need the base times the height, right? Or we need to find the AC, right? And we can use the law of sine, right? So now let's do the put the height here, land on the height, right? So let's do the, if this is the x, right? So this one is the m. So the triangle AMC, right? You have 45 degrees, you have 90 degrees, so it's 45, 45, 90 degrees, right? And the AM equals the x, right? So now we know the AC is root 2x. Okay, if AC is root 2x, then we can use the law of sine. Law of sine means a law of sine in triangle and ABC. Right, in triangle ABC, using the law of sine means root 2x over sine 75 is equal to the 18 over sine 45. Okay, then we can do is the root 2x is equal to 18, then root 2 over 2, then sine 75, right? The sine 75 is pretty simple. It's sine 75 is sine is 45 plus the 30 is sine 45 times cosine 30 plus the cosine 45 sine 30. So this one equals root 2 and root 6 plus the 4 over 2 is 4 root 2 plus root 6 plus root 2. So now we apply this one to here. Then you will get the root 2 you will get the root 2x equals the 18 root 2 times the 4 over root 2 root 6 plus root 2. Okay, and now you can use the sine, law of sine. All right, you know the SABC is equal half of the AB times AC, and the sine angle BAC, so it's equal to half of the 18 times the 18 root 2, 4 root 6 plus root 2, right? This is the sine 60, right? Sine 60 is 2 over root 2, 3 over 2. Now the final answer is 81 over 2, then 3 plus the root 3. Okay. Next. Okay, so this question, very interesting. So you can see in the diagram of this diagram, so we have a circle and we have a square, the square cutting through the circles, right? It says if the area of the shaded region of the B and A and C is equal to the area bounded by the CD, right? And the minor arc of the CD, let me use the color. So minor arc of the CD. Okay, so this part. Okay, then so the area of this one is equal to the area of this one, right? So it allow you to let you to compute the ratio of the sides. Okay, so you see they are concentric, right? So the square and the circle have a common center. So that means by symmetry, the center is the more important, right? Okay, so because how to calculate the arc? Think about it. How we can calculate the arc, right? Normally, we calculate the arc is we have to have a sector on the circle, right? Like this. If this is the sector, right? If this is the sector, okay, and you can take out the triangle CDO and to calculate this area, right? But now let's think a little bit more, okay? So here, let me notating this point is P. Yeah, this point is P, okay? So you can see, okay, the area, it tells you the area of the BAC, this area, right, is equal to the CD, right? So this is the half, right? So this is these two are equal, right? So I say this is the 1 and this is also the 1, right? So here, this part is half of the 1, part 1, right? So then if we cutting in the middle, if we cutting in the middle here, right? So this part is half of the 1, area 1, right? So this part is also half of the area 1, right? So these two are equal. So that means, okay, let's take a look at this, okay? So the area of the okay, let me use another color first. So the area of this, okay, so we can know the area of the P, let's see, this point is M, okay, the PCMO, okay, plus the half of the 1 is equal to the PCMO plus half of the 1. Okay, so that means PCMO plus half of the 1, right? That's this one. So we have a sector of the Q. We have a sector of the PQO, right? So this is the sector, right? And the other part of the PCM01 is this, right? So the other part, you can see you get a triangle. OMB. Okay, so basically you can converting this one to the two equal area, right? So these two are equal, right? Okay. Now let's assume, because I mean it doesn't matter. Let's assume the side length is 2, right? So the MO is the side length, right? Is half of the side length is 1, and the MB is the half of the side length is 1. This is the 45 degree. So this triangle is easy to calculate, right? So the area is half. Okay, but how about this sector, right? So this sector, you can see this angle is 45, right? So let's assume this is the x. So we know it's pi x squared is the whole cycle, and this is the 1/8 of the area. Okay. Now, because these two areas are equal, right? So the pi x squared over 8 is equal to the 1/2. So now you know the x is 4, but pi squared is 2 square root of the pi, right? Okay, now you already know the x, right? So let's calculate the ratio, right? So the ratio of the size of the square is 2. So the ratio of the square is 2, then over 2 square root of pi. So the ratio is root pi. Next. So in a quadrilateral